Hi, welcome back to the channel. In this video, we're going to look at how to use binomial theorem in expanding terms. Okay, let's just get started. Now, in the previous video, we've already learned how to expand something like this. And we did mention that that is binomial expansion. So we said this was n combination 0, x raised to power n, y raised to power 0, n combination 1, x raised to power n minus 1, y raised to power 1, all the way to n combination n, x raised to power 0, y raised to power n. So we're going to use the same. So this is what we call the binomial expansion. And these are the coefficients of each of the terms in the expansion. Okay, so we're going to learn how to find combination of two numbers, and then we'll learn how to use that in binomial expansion. So let's get right to the first one. So this question asks us to find the first 5 terms of this expansion, but it didn't quite specify whether we are doing it in the in an increasing powers of y, or increasing powers of z, or increasing powers of z, or descending powers of those variables. But in any ways, we're just going to look at the first 5 terms. Okay. Using this particular notation. All right. So question 1. So we have to expand this, the first 5 terms. So remember, the first one would be n combination 0. The first term raised to power the highest power. The second term raised to power the lowest power. Then 10 combination 1 is the next one. Reduce the power of this by 1 and increase the power of this by 1. Remember, we said that these coefficients are actually the same coefficients that you have in Pascal's triangle for the level of what? 10, right? So if I were to draw the Pascal's triangle up to level 10, I would find that these same coefficients, once we find them, will be the same thing as those numbers in the Pascal's triangle. Okay, so let's just continue. Raised to power 8, y over 2, y over 3 square. Then the next one, combination 3, 1 raised to power, reduce the power by 1, increase the power of this by 1. So how many times do we have? 1, 2, 3, 4. So we have one more. That is 10 combination 4, 1 raised to power 6, y over 3 raised to power 4. Okay, now that you have this expansion, what is next? Somebody's talking about it. It's just to simply simplify each term. So let's see. Remember, I told you that what n combination r is given as n factorial n minus r factorial times r factorial. So let's put that into test. So what is 10 combination 0? We already note that in Pascal's triangle, the first term is always the first coefficient is always 1. Let's see if that is the case with this. 10 combination 0 means 10 factorial, 10 minus 0, which is 10 factorial, then times 0 factorial. 0 factorial is 1. So we just basically have 10 factorial cancel. So the answer is 1. So this is why the first coefficient here is going to be 1. Okay. Times 1 raised to power 10. So we're going to write it one more time. Raised to power 0. So this is just to get the coefficients first. Then 10 combination 1 is just 10 factorial over 10 minus 1, 9 factorial times 1 factorial. So 10 factorial is something as what? 10. So what is n factorial? Is just n times n minus 1 times n minus 2, all the way to what? 3 times 2 times 1, all the way to 1, okay? So the same thing here, this is going to be 10 times 9 factorial, all over 9 factorial times 1 factorial. So this 9 factorial will cancel out, so 1 factorial is 1, so this will give us 10, which is expected, right? 10, 1 raised to power 9, y over 3 raised to power 1. Then the next one, 10 combination 2 is what? 10 factorial, 10 minus 2, 8 factorial times 2 factorial. So we simplify this. This is 10 times 9 times 8 factorial. So you can see that we are always stopping at the next factorial so that we can cancel out the terms, okay? Then 2 factorial is 2, so 2 times 9 over 2. 2 into 10 is 5, so 5 times 9 is 45. So the next term would be 45 here, 1 raised to power 8, y over 3 squared. Now the next one, 10 combination 3, 10 factorial over 7 factorial times 3 factorial. That's 10 times 9 times 8 and 7 factorial, 7 factorial times 3 factorial is just 6. So 3 factorial is 3 times 2, right? So we can simplify this. 3 here, 2, 3 here, 3, 2 here, 1, 2 here, 4. So we have 12 times 10, which is 120. So we have 120, 1 raised to the power 7, y over 3 raised to the power 3. Then the last one, 10 combination 4, which is what? So 10 factorial over 4 factorial. So let me just make some space. So let's just make some space here for that. So let's simplify this. So 10 factorial over 4 over 4 factorial times 6 factorial, that is 10 combination 4, okay? Now, what does this give us? 10 times 9 times 8 times 7 times 6 factorial. So 6 factorial will cancel out. 4 factorial is 4 times 3 times 2, okay? This will cancel out. Then what else would cancel out? 4 times 2 is 8, so to cancel this out, 3 into 9 is 3, so that's 21, 210. So the last time is 210, 1 raised to the power 6, y over 3 raised to the power 4. Now we can simplify all of this into what? Okay, let's see. We can do it. Let's just shift to the let's shift a little bit to see if we can do this. Which gives us the first term will be 1 times 1 raised to the power 10, y raised to the power, so this is just 1 plus. Now we have 10, 1 raised to the power 9 is 1, y over 3, so that will give us 10y over 3, that's the next term. The next one will be 41 over 9, y over 3 all square is 45 over 9, which is 5y square. The next one would be 120 divided by 27. So we have 120 over 27. You can simplify that into 3 here, that is 4, 3 here is 9. So that is 40 over 9 y cubed, okay? And the last one is 210 over y, 3 raised to the power 4, which is 81. So 3 can go, that's 70, 3 here is 27. Nothing else can go again, I presume. So we have 70 over 27 y raised to the power 4. So this is the expansion of that, okay? And this is in the ascending powers of y, right? Because we have power of 0, power of 1, 2, 3, and 4, okay? All right, so that's the solution to the first one. So let's just look at the second one, 3 minus 5z raised to the power 14. So all raised to the power 14, okay? Now, this would give us, again, 14 combination 0, the first term raised to the power 14, minus second term raised to the power what? 0. Then the next one is 14 combination 1, 3 raised to the power 13, minus 5z raised to the power 1. The next one is 14 combination 2, 3 raised to the power 12, minus 5z square. Then the next one is 14 combination 3, 3 raised to the power 11, minus 5z raised to the power 3. And then finally, 14 combination 4, 3 raised to the power 10, minus 5z raised to the power 4. So all I'm doing is I'm reducing the power of the first term by 1 and increasing the power of the second term by 1. That's all I'm doing. So the next thing again is to simplify. 14 combination 0 is going to be 1. We know the first term is always, the first coefficient is always 1. Now, we're not going to evaluate all of this. 3 raised to the power 14, you can do that in the calculator. And this one is just 1 as well. So we just have 1 times 3 raised to the power 14, which in itself is 3 raised to the power 14. So the first term here, the first coefficient is going to be 3 raised to the power 14. That's all. Now the second one is 14 combination 1, which is 14. Now we have 3 raised to the power 13, then times minus 5z raised to the power 1. So we need to multiply this in your calculator to find out what that value is. What about the next one? 14 combination 2, I don't know what that number is. So let's see, hopefully I can figure it out. This is, so it's 14 times 13, 14 times 13 over 2, which is 7 times 13. So 13 times 7 would be 14 combination 2. Let's see if we can find out 13 times 7. I have my calculator right here, which is just 91, right? So we have 91, this is 14 combination 2. We still have to multiply this by 3 raised to the power 12. Then multiply this by what? Minus 5 square, which is 25 z squared. So this is how we need to simplify all of these terms until we will get to the last one. So you need to find 14 raised to 14 combination 4 multiplied by what? 3 raised to the power 10 multiplied by what? Minus 5 raised to the power 4. So the last one would be this. Z raised to the power 4. And this is how we do the binomial expansion, okay? Now, these are pretty heavy numbers to multiply, so it's quite okay if you leave it in this form, right? There's no need, there's no point of evaluating each of this, unless you are strictly, even when you're strictly asked to find the coefficient of z squared, you just give them this number, right? I think the person looking at your solution would understand. And the last one, 1 minus x over 2 raised to the power 8. So let's look at this, 1 minus x over 2 raised to the power 8. Again, this is going to be 8 combination 0, 1 raised to the power 8, minus x over 2 raised to the power 0. I think you can now see the pattern, right? And it's quite straightforward. Square, then 8 combination 3, 1 raised to the power 5, minus x over 2, 3, then 1, 2, 3, 4. So the last one, 8 combination 4, 1 raised to the power 4, minus x over 2 raised to the power 4. Okay, now let's do the first one. 8 combination 1 is obviously 1. So that is 1. 1 raised to the power 8 is also 1. And minus x over 2 raised to the power 0 is also 1. Okay, so the next one, 8 combination 1 is 8. So you have 8 there, times 1 raised to the power 7, which is 1. Then we have times what? Minus x over 2. So we'll simplify this. The next one is 8 combination 2. Let's quickly do this. This is 8 combination 2, which is 8 times 7 over 2. 4 times 7 now is 28. So this is 28. 1 raised to the power 6 is 1. Then we have minus x over 2 squared. So we'll simplify this later on. What about 8 combination 3? That will be 5 factorial, 3 factorial. So 8 times 7 times 6 over 6. So that's just 8 times 7, which is 56. So we'll have 56 minus x over 2 raised to the power 3. Then the last one, 8 combination 4. So which is 8 times 7 times 6 times 5, all over 4 factorial, which is 4 times 6. 4 here will go as 2. So that's 10 times 7, that is 70. So we have 70 minus x over 2 raised to the power 4. So we can just simplify this now. Now 8 can go into 2, 2 can go into 8 as 4. So we have, we have minus 4x. So let me just make it. Because of the minus coming from minus x over 2, we have minus 4x. Then here we have 28 times x squared. So for this, 28 times x squared over 4, because when we do minus x over 2 times minus x over 2, that becomes plus. So 4 into 28 is 7, so you have plus 7x squared. What about the next one? This becomes minus 56x cubed over 8, because 2 raised to the power 3 is 8. 8 into 56 is 7, so you have minus 7x cubed. And finally, the last one, we have 70 times x raised to the power 4 over 16. So this is basically 35. So 2 here, 8, 2 here, 35. Nothing else can go. So we just have plus 35 over 8x raised to the power 4. So, all right. So this will be the solution to this particular problem. Okay. Now, so this is the first 5 terms. If they ask what is the coefficient of x cubed, the answer is just going to be minus 7. Okay. So what the mistake that most students make is they don't simplify. Before you give the final answer, the coefficient of x cubed is not 56. It is not 56. It has to be when you simplify 56 with whatever number you have coming from this minus x over 2 raised to power 3. So take note of that. All right, and that brings us to the end of the video. I will see you guys in the next video. Make sure you subscribe to the channel and like the video and share in your other social media platform. See you guys in the next one.